So let's get started. So my name is Jose Barreto. I'm a principal program manager with the file server and clustering team at Microsoft. And this presentation is all about the Hyper-V over SMB scenario. This is when we use virtualization with file storage in the Microsoft platform, okay? This is a new scenario in Windows Server 2012. And we are going to be talking about a lot of details about exactly what we mean by this scenario, how to configure it, and we'll also offer some end-to-end configurations so you can see it, and hopefully we can show some interesting demos as well. Okay? A few things. This is not a Hyper-V overview. We assume you're familiar with Hyper-V, you know what Hyper-V is. This is not about block storage. We're not going to talk too much about Fiber Channel or iSCSI. We're going to focus on the file protocol SMB 3.0. All right. So as I said, an overview, some configuration details, performance considerations, which always comes up, and samples. Let's start with an overview. So what are we talking about here? So in the past, before Windows Server 2012, if you were configuring storage for your VMs in Hyper-V, you would essentially have the option to go with directly attached storage, like a SAS or SATA drive, directly attached to your virtual machine host. You could do iSCSI storage, or you could do Fiber Channel storage. You had those three choices. If you wanted to have a clustered Hyper-V server, and who doesn't, right? You would have to use either iSCSI or Fiber Channel. In essence, you had to use a SAN, okay? And in this release for the first time, we're offering you the ability to use a file share, meaning you can actually have a separate machine where you run the SMB server, the file server, and instead of specifying C, column, cluster storage, volume X, something, you would specify // server name, / share name, / something. First question I get asked, oh, is this for backups? Is this for the library? No. This is for the running VHD files. This is for your configuration. This is for your snapshots. This is for your live VMs. And folks will start talking about, oh, okay, that's interesting, that's new. Can you guarantee that we are going to have a solution that works as well as my iSCSI SAN, as my Fiber Channel SAN? Well, the answer is yes, because we spent this cycle in Windows Server 2012 looking at specifically what block storage had that file storage didn't. And we specifically addressed the issues that were there. And we believe that with the changes we put in place in Windows Server 2012, we have file storage that you can consider first-class storage. It's not like there's Fiber Channel and iSCSI and file storage is over here. No, they should be all at the same level. Now, I saw an interesting shirt coming in today, right? It's, the thing that was written was basically, I will not believe on anything you said until I test it myself. And I love that. And I do encourage you to do that testing. But I want you to focus on a few things that we made new in this version of Windows Server that specifically addresses gaps that we used to have. First of all, transparent failover. Are you guys familiar with the notion of a dual controller SAN? Why would you go with a single controller versus a dual controller SAN? Well, a dual controller SAN allows you to update the firmware on the controller without stopping your access to the storage, because you can actually update firmware on one controller while the other one is actually providing storage to your clients. In file server storage, what happens if you need to update a node, if you need to apply a patch, if you need to change a power supply, if you need to add memory, right? What you typically had to do before is to say, I have to shut down the file server to address that issue, and then I'll bring it back up. That means stopping service. So in Windows Server 2012, you can have a 2-node file server cluster, and we will transparently move the workload between nodes. So let's say you have 1,000 VMs running on file server node 1. You can actually turn off that server without any notice, and all that workload will move to the other one. We'll talk more about that. Scale out. If you have multiple file servers, we have the ability to spread the load across the nodes of a cluster. So instead of having a node that's just waiting for the other one to fail, you can have multiple nodes that are all active at the same time. That's also new. SMB Direct, which is the ability to do very low latency, very high performance. Scenarios for this are exactly related to fiber channel comparisons. So let me rewind a bit. When we started this, folks were saying, oh, okay, you can do file storage, and that's all nice, but that's always going to be going through TCP/IP, right? So you'll never be able to be as fast as fiber channel. And our answer to that is in SMB Direct. When using SMB Direct, we can provide that high throughput, that low latency, and we actually completely bypass TCP/IP to get the highest throughputs that I have personally seen, bar none, right? And we'll show some of that. Multi-channel, you familiar with MPIO? So multiple paths to the storage, you can leverage them at the same time. So that means if you have 2 NICs, they're each 10 gig on each box, you can actually achieve 20 gigs of throughput on a single file, right? That is multi-channel. We also do encryption. We have a backup solution for VSS, and we have full support for PowerShell. Well, let's dive a little deeper on each one. So start with transparent failover. So as I was explaining to you, this is probably the most important feature we have, because what it does, it allows you to have a 2-node file server cluster or larger, where you have your workload running. And if for some reason you need to do maintenance on one of the nodes, you can safely just move the clients to the other node. We call that a planned failover. You can actually do something, restart the node at any time. The load will just shift to the other node. And that's all transparent to the workload, by the way. From Hyper-V's perspective, there is really no outage. What happened is I was sending I/O to a disk, to a share, and at some point, one of the I/Os took a little too long, and then it went and it continued, right? So you never see an error from a Hyper-V perspective, okay? I'm focusing on Hyper-V here, but this is also the case when we're doing SQL Server over SMB or even regular clients over SMB, okay? All right. The other thing is that you know you're going to have maintenance. You're going to have hardware maintenance. You're going to have software maintenance. But sometimes you have what we call a surprise failover, meaning you're running here, and for some reason, your fan stopped working, or something bad happened to your memory, and you just simply crash, right? And if that ever happens, what are the guarantees? So the same thing will happen. So we have services in place that detect that issue through cluster, and will again transition to another node while the workload is running. The way we test this is we simply pull the plug on the machine while it's running, right? And we observe that the handles are properly transitioned. By the way, this is not a trivial thing to do because SMB is a stateful protocol, meaning if you have an open file, you could have locks on that file. You have your current position on that file. And when you transition over to the other node, the other node has to resume that file open at the exact same state that it was on the other side, right? And there's some tricky things too. Let's say you're renaming a file, or you're creating a folder. What happens if right in the middle of a rename, something fails? So it could be that it failed before the request ever hit the server. It could be that it failed after it hit the server, the file was already renamed, but you just didn't get your response back. So just replaying the operation doesn't work. There has to be more intelligence to say, oh, you're trying to resume this operation? Oh, what is your current state on that? Oh, I see. We actually already renamed the file. We just didn't send you the response. So instead of trying to rename the file again, we'll just resume what we were doing, and we'll send you the response back. And again, Hyper-V or SQL, or whatever is the client using that file server, will not see an error. You can inspect that in the SMB logs to see, oh, yeah, in the middle of this, we actually have an issue, and we resume that on another node. You can inspect that if you want. But that's the idea. A few things. Obviously, you have to be running cluster. You have to be running Windows Server 2012. And you have to enable something we call continuous availability, which is on by default. It's enabled by default when you create a share in a cluster now. Okay? All right. Scale up. If you're familiar with clustering, you know that typically what happens is you have a cluster role. That cluster role is active in one of your cluster nodes at a time. Okay? So before 2012, if you had a file server, that file server would be active, say, in node 1. If that failed, that role is transitioned to another node and is started on that node. But for a given file share, at any point in time, we would only use one of the many nodes of the cluster. Now, in 2012, we have a new way of doing things, which we call scale-up, which we recommend for the Hyper-V scenario. What does it do? It essentially uses cluster shared volumes as the location for your file shares. So you create the share on a cluster shared volume, and that share shows up in all the file server cluster nodes. So if you have, for instance, a file server cluster with 4 nodes, all 4 nodes of the cluster will have that file share running. Well, if you understand how CSV works, you know that the CSV volume shows up in all nodes. So that was the hardest part, right? It was to make that data available on all nodes. Now in SMB, we now expose that through every node of the cluster. We now have a single name. That single name, if you look on DNS, has the IP address of all the nodes in the cluster. And as the client come in through DNS round robin, we will choose one of the nodes. And if you have a lot of clients, let's say you have 100 Hyper-V hosts talking to this cluster, they will distribute across the physical nodes, and then you can pull that data from across the nodes. So if each node has a 10 gig NIC, if you have 4 nodes, you can effectively pull 40 gigs of throughput out of that cluster, assuming that whatever storage backend you have can keep up with that demand. Okay? There's a few interesting things there. Because we're using CSV, we now have access to this thing that we call CSV caching. So you can do a very efficient caching for CSV now, and we fully leverage that. We also have the ability to do check disk with zero downtime. Not sure if you know this about the new check disk. So when you're doing a check disk now, we can do the scan live on the volume. So you don't need to take the system down to do a check disk. And then whatever is remaining to do, a few fixes, we can typically do it now in seconds. That's without CSV, just a regular disk. You do a check disk, you'll do the scan live, and for the fix-up, which typically is just a few seconds, you have to take downtime. Now with CSV, it does an interesting thing. You can do the scan live, and when it's time to do the fix, These are so fast that CSV does this. It dismounts the volume, pauses all the I/O, applies the fix, and then brings the volume back. And you actually never have to stop, right? So we leverage that, this check disk of zero downtime, because our data store is now on CSV. So these are just a few of the tricks that we can do. SMB Direct. I love that one. We're talking about SMB Direct and how it is our story when you're trying to compare a traditional fiber channel SAN with a file server. So the challenge was this. So when you're using fiber channel, you're using something called a fiber channel HBA, right? What is a fiber channel HBA, really? It is a card that will do a lot of work on behalf of your system. So when you say, write this data, it will actually take the entire set of data and will do the I/O by itself. It has logic to do that. And it can do it very fast and can do it with very low latency. Now, we wanted to match that, but we look at what we had and we say, okay, so regular network interfaces use TCP/IP. There are certain things we need to do. If you have a large I/O, you have to chop it in small pieces and do all kinds of things. And it will take a while. We can never reach that latency. And then we stopped and look at the folks that do high-performance computing. And the guys that did the HPC server, I'm not sure if you're familiar with that, they had these NICs, these network interfaces, that were able to do this very fast, very low latency transfer between systems that they called remote direct memory access. So what does it mean to do RDMA? Doing RDMA means you have some data that has to go from system A to system B. Typically, let's say it's 512K. What you have to do, you have to slice that in small pieces, then each piece gets transmitted through TCP/IP, it gets received on the other end, then it gets reassembled and put in a buffer. That's a lot of work for both CPUs. What RDMA can do is on one side you say, hey, I have this 512K of memory to transmit. And it sends that information to the NIC. And then said, now go transfer to the other side. Then the other side gets a request that says, I need you to transfer this data, and here's a token to the memory on the other side. Then the two NICs essentially talk to each other. They do the entire 512K transfer without ever chopping the data. They pick it on the source location, and they drop it at the destination exactly where it needs to go. And it operates at the maximum speed that the NICs can operate, right? So if you think about it, that is really close to the kinds of latency, the kind of way to operate that fiber channel has. And the only problem is it was very hard to code because it's an entirely different process. You don't just send data. You have to do registration, send registration with token, and then on the other end do receives and do, they're all different kinds of basic constructs that look nothing like TCP/IP. So we basically had to build a new protocol and a new stack for that. We call that SMB Direct. Now the beauty of this is that you don't have to learn anything about it, because what we do is if we find that we have a NIC with that capability, we'll use it. So there is no configuration. All you have to do is load the NIC. These NICs have IP addresses in the same way. You see them and you right-click and you say properties and you add an IPv4, IPv6 address. They can do DHCP. They have a side-by-side TCP stack. When SMB looks at that, it talks to the other side, gets a list from the other side and say, hey, can you both do RDMA? Yes. So after negotiation, it will simply stop using TCP altogether and shift into RDMA mode. If you're looking this with Wireshark or Netmon, you're going to see negotiate, query information, then silence, because you're no longer doing TCP/IP, okay? Now, if at any point you don't have an RDMA interface, that's fine. We'll fall back to whatever you have, which takes me to the next one, which is multi-channel. Multi-channel is the ability to use multiple TCP or RDMA connections per session. So today, before 2012, if you go between, say, 2008 R2 and 2008 R2, and you have 2 NICs on this side, 2 NICs on this side, what SMB does, it uses one. Not only it uses only one of the 2 available NICs, it does only one TCP connection between the 2. Okay? That used to be fine when you had like 1 gig NICs, but as you start to go into faster NICs, having one TCP connection is not enough. Because what happens is when you're doing TCP IP with a single connection, the way the stack works is that it will affinitize with one of the cores. So if you have a machine with 16 cores, and you're doing a file transfer with a single TCP connection, you're only engaging one of your 16 cores. Now, if you have 4 connections, you will engage 4 cores. So what we do now in the version 3 of SMB is we look at the capabilities of the NIC and we say, can you do receive side scaling, which is this ability to kind of spread TCP connections across cores. If the NIC says it does, we will create multiple TCP connections automatically. That's one thing. So that right there will give you benefits when using fast networks. Now, if you have multiple NICs, say you have 4 1 gig NICs here, and you have 4 1 gig NICs on the other side. With multi-channel, we discovered that that is happening, and will automatically create multiple connections, one on each interface. So what you get effectively is 4 gigabits of throughput out of 4 1 gig NICs. Okay? What do you have to do to get that? You have to configure the NICs. That's it. There's nothing else you need to do. You don't need to tell SMB which way to go. SMB will simply on one side say, oh, you want to go to this server. I'm going to query through SMB. How many NICs does the server have? What are the IPs? What is the speed? What are the capabilities? You get that response back. The client builds a map and says, oh, I think I can use 4 paths. And it will do it. It will always start with 1 because there are no guarantees the other side is actually doing SMB3 or that the other side will be able to do multi-channel. If it confirms that, it will actually automatically engage. So what you should see, if you start a copy, for instance, over that, you will see that we start at 1 gig, and about 10 seconds later, we'll start adding 1, 2, 3, all the way up to the max that you can do. And it will stay there. Okay? SMB multi-channel is really reevaluating that at regular time. So even if you lose a NIC, let's say you disconnect one of the 4, you drop to 3 gigs. But if you reconnect that, it will go back up to 4 gigs. In fact, there was one side effect that we didn't plan. This is a server feature, right? But because of that, let's say you have a notebook running Windows 8 talking to a file server. You're roaming about, and you start a copy. Then you look and say, oh, this is huge. This is going to take a long time over wireless. So just take that Windows 8 machine back to your docking station, dock it, and multi-channel will detect that you now have a 1 gig NIC, and it will switch over from the wireless to the 1 gig and continue the copy without ever stopping. And you can do the other way around too, right? So this is the kind of resiliency we're building on the stack. Encryption. Another fun thing, a lot of folks talk about encryption. I always like to ask this. Who here is using fiber channel with encryption? As usual, no one. It does exist, though. So who's using IPsec? Yay, a few folks. How was it? Well, IPsec works well with SMB, by the way. You can definitely use it. The problem is it requires a private key, public key infrastructure, a PKI infrastructure. And it also requires you to have group policies to deploy the IPsec policies and all that. And sometimes that's a big project. What we did with SMB was something simple. In SMB 3.0, you can now, per share, just say, yes, check a box and say, I want to do encryption. Okay? Or in PowerShell, you do a dash encrypt data when you're creating the share. What it does is SMB already has a secret that is never shared over the wire between client and server. That's how we do our authentication, okay? So what we do, if you select encryption, is we'll use that secret to derive a key, and we will encrypt just the SMB session, okay? What do you have to have? Really nothing. All you have to do is set a bit on the share properties. Do I need PKI? No. Jose, that means you're not using public-private key? No. In fact, if you know your encryption, you know that the public-private key thing is just so you can derive a session key. You actually don't use those keys for every transfer, right? So at the beginning of the session, when you're using PKI, you create a session key, and then you use that session key throughout the session. Guess what? SMB already has a secret that can be used to derive a session key, and that changes with every session. So we just use that. We're also using a type of encryption that the modern CPUs can help with, so the performance impact should be minimal. One more thing we did is we have the ability to do backups using VSS. That was also an interesting one because you can never have a storage solution that doesn't have a nice backup and restore story, right? And when we're using backups and restores in Windows, we always hear about volume shadow copy services, right? VSS. And interestingly enough, the V in VSS stands for volume. And a share is not a volume. So we actually had to do a significant amount of work to make so that VSS could perform a backup using a remote file share as the data location. And that's essentially what we're doing here. So you can see that your backup server will talk to the agent running on, say, your Hyper-V box, and it will use this new file share shadow copy provider to go remote to the file server, and then say that this is your data volume, \\fs/foo. Then when you create a snapshot, it creates another share that has the shadow copy, that has the snapshot. So we actually do the snapshot on the remote machine, and we provide you with a share. It's actually, the shadow copy actually has a GUID in the path to be unique, so we don't put a GUID there to make it simpler. But that's basically our full integration with VSS. So far, so good. So I hope you understand by now that we put a lot of effort into this, right? We took what used to be a solution for storing Office documents for end users to do like PowerPoints and Word documents, and we now have in SMB 3.0 a solution that allows you to store your live server workloads with reliability, network fault tolerance, backup solutions, performance. But there's several different things that we put in place to make that happen, but there are several different ways that you can deploy it. And I want to kind of quickly go over some of these. First one, option A here in the slide, is just a standalone file server. So, Jose, you mean I can actually get a few Hyper-V hosts and store my data in a standalone file server? Yes, we do not recommend that. Why is that? Because if you remember what I initially talked about, this is all about availability. If you have a single file server, that is a single point of failure. That is the equivalent of having a single controller SAN. Do you have a single controller SAN? If you do, you'll never be able to do any service on that SAN unless you take downtime. So that's the same thing here. You can do it. You can even create a Hyper-V cluster with that setup. But for me, that's kind of weird, because if you're thinking about high availability on the Hyper-V side, you should be thinking high availability on the storage side as well. But some folks like to do that just because they want to be able to recover from an issue on one of the machines, and that will save you from some things, but it's definitely not a highly available solution. What we most of the time talk about is at least a 2-node file server cluster, which is option B. And how many of you have heard of storage spaces? We've been talking about this for a while. This is a great solution for a industry standard hardware, JBODs and disks combined with a file server to provide an end-to-end storage solution. So you can just have a few shared sets. So you can imagine a JBOD over there connected to both file servers that is enough to create a scale-out file server with transparent failover, and that's a great solution to store your Hyper-V files. Okay? That's option B. There's also option C. So in many situations, we have folks that already have a large investment in fiber channel SANs, and they have a few thousand spindles, and they want to leverage SMB 3.0. So what sometimes they do is they put a set of file servers front-ending that fiber channel solution. And folks sometimes get puzzled with that and say, okay, Jose, I don't quite get it. If I have fiber channel, I can just wire fiber channel to everyone, right? Yes. But let's imagine you have 100 Hyper-V hosts, okay? And you want to wire to that large fiber channel array that you have. How many HBAs do you need? 200, right. How many ports on the fiber channel switch do I need? More than 200, right? How much is that switch? Some good amount of cache. So one thing people do is they wire just the file servers to the fiber channel infrastructure. So let's say you have 4 file servers. How many HBAs do you need? 8. How many ports on the fiber channel switch? 16 should be fine, right? And then you can wire the whole thing up, and then from the file server to the Hyper-V hosts, you can use regular Ethernet networking. Okay? That makes sense? Speaking of networking, there are many different ways to configure that networking, right? Another thing you can see here in terms of options is on A, you're all 1 gig. And say, Jose, you were talking about 10 gig and all that. Yeah, we like to talk about the big stuff. We also like to talk about the smaller configurations, right? So if you have 2 1 gig NICs, you can wire that to your Hyper-V hosts, and you get some amount of throughput. So how much throughput can you get out of 2 1 gig NICs? 2 gigs of bandwidth, very good. In bytes per second. About 220 megabytes per second, right? Is that too much, too little? Depends on the workload, right? I've seen folks that did 8 1 gig NICs combined. And by the way, that's still the most cost-effective networking solution, if you can get away with it, is 1 gig networking, right? There's nothing cheaper per port. It's really good. Now, sometimes you outgrow that, and you need 10 gig NICs. So with a 10 gig NIC, how much throughput can I get in bytes per second? About 1,100 megabytes a second, right, at line rate. So that's good. If you have 2 of those, you can get over 2 gigabytes a second, which is awesome, right? That is a whole lot of IOs. How many 8K IOPS is that? Come on, where's the math guys in the room? It's a lot. It's a couple 100,000, right? So that's not bad. If your storage can keep up, that's a great solution. You can also use faster solutions. We have 40 gig Ethernet available. We have 32 gig InfiniBand available. We have 54 gig InfiniBand available, which can give you more, okay? And if multi-channel, you can actually aggregate. The last one is an all 10 gig, because in the first one, see, your clients are still connecting through 1 gig. On C, we have an all 10 gig, all the way to the clients, right? And some people are there. And on D, we have the mythical converged Ethernet. right? Converged network data center, right? Where everything is connected through the same network infrastructure. How many people are doing D right now? A few folks. That's awesome, right? So if you are already there, the file storage becomes more and more interesting. But you can start small and you can grow into it. How do you do it? Let's get really practical here. So the way you implement this is very simple. On your file server, you create a folder. That's one. Then you create the share, and we now have PowerShell for it, new SMB share. And then you have to give permission to the administrator, the Hyper-V administrator. You have to give it to the computer accounts of the machines that are going to access the share. Okay? So the names of the Hyper-V machines themselves. And if they are clustered, also to the cluster account of the Hyper-V cluster. Okay? Last thing you have to do is apply the permissions to the folders themselves. You can use the PowerShell or iCackles to apply permission. We have a little trick here in option 3, which is something we built that lets you get the permissions from the share and just apply to the folder. So if we just created that share with those 4 full permissions for those 4 objects, if you use that line below, it essentially gets from the file share a set of preset permissions that you can just then apply. That's the full command. So that basically, that last line means get whatever share permissions I have and make those my folder and NTFS permissions, just to simplify. Okay? Cool. How about on the Hyper-V side? Couldn't be simpler. When you create your VM, instead of using drive, colon, backslash, folder name, you use backslash, backslash, file server name, backslash, share name. That's it. You can create the VHDs, you can create the VMs, you can create snapshots, whatever you want to do, just use that. And if you're using the GUI, in the GUI, just specify the path. That's about it. All right? A few notes, and this will probably preempt a few questions you have in your mind right now. First of all, you have to use version 3.0 of SMB. After all I told you, you probably don't want to live without transparent failover, without multi-channel. Those are the key ones. Because we want to have a file solution that is reliable, network fault tolerant. Okay? In fact, so much so that the Hyper-V team has said that if you're not using SMB 3.0, you're not supported. So for the Hyper-V over SMB scenario, 3.0 is a requirement. Okay? That means 2012 on the server, and that means 2012 on the file side, or a third-party SMB implementation that implements 3.0. Okay? Active Directory is required. If you think about the permissions, we use computer accounts in the permissions. Are there computer accounts when there is no AD? No. So no AD, no Hyper-V over SMB. It is a requirement. It's also a requirement for cluster, by the way. Continuously available shares are highly recommended. So don't use standalone servers, use cluster servers, and use the default CA settings. Okay? Loopback configurations are not supported. That's a fun one. So if you have a Hyper-V host, you can make the Hyper-V host also a file server. And then you can try to actually store the thing through the UNC path on the same machine. Don't. Okay? If you are on the same machine, just use the local path, not the UNC path. Why would you do that? Oh, I'm trying to test it out just to see how it works. Okay, that's not how it works. You need 2 machines. Okay? Why is that? It is because our permission model uses computer accounts. If you're doing loopback, that permission model doesn't work. Okay? That's the technical explanation why it wouldn't do. The other thing is, if you're doing clustering, you need 2 clusters. 1 cluster for file server, 1 cluster for Hyper-V. If you use a single cluster, what can happen is at some point, your VM might fall in the same node as your file server, right? When that happens, what you have? Loop back. Then it doesn't work. So if you want to do clustering, you have to have a cluster for Hyper-V, cluster for file server. Okay? Jose, what if I only have one cluster? Then you can use CSV, right? On that cluster, you do CSV, and you're all good. You use C column cluster storage as your path. You don't need file servers. That makes sense? All right. You also, if you're using Virtual Machine Manager, you need to be using 2012 SP1, which has support for this scenario. And there are different options for remote management. All right. That was the basics. We're now going to move into performance, okay? The main thing I get is folks keep asking me, Jose, can this perform? How good is this? So how many of you watched the keynote? So you saw that we're showing SMB performance compared to local performance. It should be almost the same, okay? We test this extensively, and it's usually, even with traditional networking, within 5% of each other. So what you need to do is you want to make sure that your storage performs. SMB should be just fine, right? You also want to make sure that your network performs. And when we're doing RDMA for your network, we are typically the same, remote and local. I really mean at the same level, within 1 percentage point of each other. And sometimes SMB is faster. And it doesn't make sense at first, I know. How can remote be faster than local? It's the way you queue, right? But what I'm saying is just basically, it's no real challenge for a file server to keep up with this kind of workload if you're using modern hardware, okay? We have demonstrated hundreds of thousands of IOPS. We have demonstrated multiple gigabytes per second of throughput. Now, having said that, you do have to design thinking about the whole solution, okay? This is my attempt of putting as many boxes in a slide as possible. So we have multiple layers here. We have our JBODs. By the way, I'm using a storage spaces example with JBODs. There are other options here, but let's start here. So I have a 2-node file server. I have 3 JBODs. I have a whole bunch of Hyper-V hosts here. And I have my management infrastructure over here, and I have my clients. So imagine this is, for instance, you're running a few hundred IIS hosts with SQL inside the VMs and all that. And your clients here are the ones accessing that workload, which lives in the VMs, right? First thing you see is that I have multiple JBODs, multiple HBAs, multiple NICs at every step of the way. Why is that? Is that mindset that you need 2 of everything, so you are fault tolerant. Jose, do we actually need 2 of everything? No, you don't. However, if that thing you have only 1 of fails, you're down, right? And that is not specific to file services. That is overall high availability, right? Same thing if you're doing fiber channel. You want to have 2 HBAs, always, right? Or else someone pulls a cable and you're down, right? Or a switch fails and you're down. You also see that I have dual switches everywhere. And there are a few points here where you need to think about performance, right? A few notations here. So in this side here, you have the SAS. Where's my mouse? My mouse disappeared. Never mind. You see on the right there, you have the SAS infrastructure connecting your file servers to your JBODs. Then between the Hyper-V hosts and the file servers, you have the RNICs. So that's my short for RDMA NICs, right? Jose, do I need RDMA NICs? No. You can use regular NICs as well. This is just my typical configuration. Then on the other side, you have my non-RDMA NICs connected to a team, making a single team of the two NICs, and then connected to the vSwitch and going to the virtual machines. Notice that SMB does not flow through that path. It flows through the storage VSP, VSC, and Hyper-V. So the Hyper-V of SMB traffic is considered storage traffic in Hyper-V, right? All right, few things, so more boxes. And these are all the things that you have to keep in mind when you're thinking about this configuration. Every one of these things in those boxes represents something that could impact your performance, okay? How many SAS ports per module? Are you using 3 gig SAS or 6 gig SAS? How many disks do you have? Are those SSDs or hard disk drives? How many HBAs do you have? How many connections? How many NICs do you have? How fast are the NICs between the virtual machine host and the file server, right? Are you using storage spaces? How many columns per space? How many spaces? Are you using CSV cache? How big is your CSV cache? That has direct impact to performance. Also, how many VMs per host? How much RAM are you using for each VM? How many virtual processors? How many processors you have on the machine? How many cores? How much RAM overall? How many hosts? Do you have 5 hosts? 10 hosts? That all impacts performance. Okay, that's a lot to take, but that should be a day in the office for anyone planning a private cloud solution, right? Let's try to make it a little bit more real. Let's say you are tasked with creating an infrastructure to run 500 VDI VMs. And each VM has 2 gigs of RAM and 1 virtual proc. Jose, 2 gig is too much. 2 gig is too little. Doesn't matter. It's just an example. You have your requirements, plug them in here. For each VM, we're offering 50 gigs of storage, that's capacity, and we need an average of 30 IOPS. Jose, 30 IOPS is too little, too much. Doesn't matter. Plug in your number. It just happened that I saw a study from a colleague on mine in the performance side that said 27 IOPS is the average he saw in a VDI deployment, so I put 30 there. You could double it, you could half it. Just do the math. Now, I'm using 900 gig, 10K disks, okay? They each give me about 140 IOPS. And it will vary. You can get a different model. You can get a 15K. You can get an SSD. Do what you want. Plug the numbers. I have 2 models of JBOD that I can use. I can use a 24-disk JBOD and a 60-disk JBOD. My Hyper-V hosts use 16 cores. They have 128 gigs of RAM. Could have more, could have less. Just do the math, right? Then some calculation. 30 IOPS per VM times 500 VMs divided by 140 IOPS per spindle. That gives me what? 107 disks, give it or take. That's per IOPS. If you think in capacity, I have 50 gigs per VM times 2. Why? Because it's mirrored, right? Times 500 VMs divided by 900. And say, Jose, 900 gigs actually only give you 850-something usable. Do your math. This is just an example, okay? And you get about 56 disks. So what do you go with? 107 disks because of IOPS or 56 disks because of capacity? You do 120, right? You go a little beyond that. And it just so happens that 120 is 2 times 60, which is a nice JBOD configuration. So let's do 2 JBODs, 60 disks each, 120 disks, some spares, some spare capacity never heard, right? You have enough capacity to have backups in there, snapshots and such, because from a capacity point of view, you only need 56 disks anyway, right? So you're doing it mostly for IOPS. Now, Hyper-V host, you have 2 gigs per VM divided by 128. It's about 50 because you need to leave some RAM for the host. Jose, what about dynamic memory? Do your math, right? You can do all those things. It's just an example. 50 VMs times 1 virtual processor per VM. It's 50 virtual processors. Divided by 16 cores, you have about 3-to-1 ratio on virtual to physical cores. That sounds about right. How much is too much? It depends, right? Typically, anything less than 4-to-1 is fine. I've seen folks do more. I've seen folks do less. So we have 500 VMs divided by 50. That gives 50 VMs per host, right? So it's about 10 hosts. We'll add 1 for good measure, because we want to be able to kind of do servicing on 1 node at a time and still have enough left. So 11 hosts it is. Then we have networking. So we have 500 VMs doing 30 IOPS, and I put 64K average I/O size. Could actually go a little lower for a VDI workload, probably more like 32. But anyway, I'm being on the safe side here. So that's about 937 megabytes per second. Okay? A single 10 gig gives you about 1100. You have 2 for fault tolerance anyway, so you're fine. So you have 2200 megabytes per second throughput available here on either node, and you only need 937. So you're good on the networking side. Now on the SAS backend, a single 4-lane SAS at 6 gig gives you about 2200. You have 2 anyway for fault tolerance, so you have plenty on the SAS side to keep up with what you have on the networking. File server, you have, you know, a healthy number of IOPS there. That's actually, that should be 50. Anyway, but a single file server will be able to keep up just fine, right? There's no big stress there. It says 25, it should say 30 IOPS. But anyway, I've seen a single file server with a Romley 2-socket machine do a few hundred IOPS. So you should be fine. And one thing you have to think about is RAM. So you want to have enough so you can have a good CSV cache. 64 gigs is a fine number. You could go bigger. 64 is fine. You could go a little lower. 32 probably do fine as well. You have less memory for cache. You can only use 20% of your RAM for CSV cache. So you have to balance that. Okay? So how does this show in the end? So 500 clients, right? 2 gigs per VM, 50 VMs per host. Here's my 2 RNICs at 10 gig, 8 mirrored space, 16 columns, and then you have the 4, and you can kind of do the math. How do you know you did a good job in terms of performance? It's not when you achieve the maximum possible performance in the world, right? How do you know you did a good performance job? First of all, you satisfy the workload requirements with the minimum amount of resources. You have some capacity available so you can have failures in one or other components, but you don't have too much going on here. You're not overspending on any side here. In fact, here, if you look at it, we're a little bit over-provisioned on the SAS side. You could actually use 3 gig SAS for this solution. But that's fine. You could add more nodes if you grow capacity. So you're going to have to think a little bit. But overall, you have a somewhat balanced set of components. And that's what really matters. And again, making sure everything is redundant. Talking about speeds and feeds, right? We're right now, if you look at this, we're just throwing some numbers at you so you can do some quick math. So a 10 gig NIC gives you about 1.1 gigabyte a second. A 56 gig NIC gives you about 6.5 gigabytes per second. An HBA at Fiber Channel 16 gig HBA gives you about 1.5. SAS gives you about 2.2 for every 4-lane 6 gig SAS, right? That's the math. You also have to look at your PCIe Gen 2 or Gen 3 slots because they also have limits. If you put this InfiniBand card here on a Gen 2 by 8 slot, you're going to be limited by the speed of the slot, not by the speed of the network. If you put a SAS 6 gig interface on a PCI Gen 2 by 4, you're going to be limited by that, not by the SAS HBA. You just have to keep those things in mind. And just to kind of keep your mind kind of thinking about overall system limits, this is the speed you can access RAM, right? Depending on the kind of RAM you're using, right? You see, even at these, the maximum RAM throughput that we have these days is about 18 gigabytes a second. Just keep that in mind. Now, this is bidirectional, so you can actually do twice that much because you're reading and writing, right? So, but just keep those in check. Few variations. You can do third-party NAS. So both EMC and NetApp are offering SMB 3.0 solutions. Samba is already offering 3.0 as well on Linux. That's an alternative. You can use SAN instead of the SAS JBOD. That's a fine alternative as well. You can use Fiber Channel or iSCSI instead of SAS. You can use regular NICs instead of RDMA NICs. All right, let's do a demo. Yeah, it's almost like I was predicting it. Yay, we're on. Okay, let me show you a few things about this setup. So let me start on the file server side. On the file server side here, what I have is a nice 2U machine that has 48 SSDs connected through 6 SAS HBAs. So each SAS HBA connects to 8 SSDs, right? I'm using storage spaces, and you see here that I have several pools. Each one of these pools, if you look at them, has 8 SSDs, so each about 167 gigs. And then you create a pool, and out of that pool you carve a space, so 1.3 terabyte. So times 6, we have what? A little over 7 terabytes available on this machine. I also created some file shares, so 6 file shares, 1 per volume. This is a standalone configuration. All right? If you're a Hyper-V kind of person, you're probably doing a lot of PowerShell, right? Not just GUI, so we can definitely do that as well. So you do a get physical disk. You can see the disk configuration here. So you see disks. If you do a get storage pool, you see the 6 storage pools. And if you do a get virtual disk, you can see my spaces. So each space with 1.3 terabytes. And finally, you get SMB share. You see that I have my 6 SMB shares over here, right? All nice and good. Enough about the file server. Let's switch over to my Hyper-V host. This is a diagram of what we have, right? This is my background image here. So 6 SAS HBAs going to SSDs. And then I have 3 high-speed RDMA NICs connecting me to this Hyper-V host, which I have, where I have 12 virtual machines. That make sense? So let me start by looking at the Hyper-V configuration. So I have a whole bunch of Hyper-V VMs running here. How can I tell that I'm doing Hyper-V over SMB? So you go at the properties, look at the hard drive, and you see here that I have a remote file path. So this is actually doing Hyper-V over SMB. It's really all it takes. If you look at these VMs, they are essentially each one running a script. And the script basically does this. If a file exists, run this test. If it doesn't exist, wait 10 seconds. And it keeps in the loop. So I have the VMs waiting for some workload here. Before we do that, though, I'm going to go ahead and bring up my performance monitor. And I'm going to bring my PowerShell prompt here. So I'm going to simulate some workload. I have my cheat sheet here. So this is a SQL I/O simulation. We're going to start by doing some large I/O. So if you're familiar with SQL I/O, I'm doing 512K I/Os with 2 threads. So that should give a good jolt there. So if you look here, in this configuration, from the parent alone, we're doing 16.8 gigabytes a second. Let that sink in for a bit. So this is the equivalent of, say, 15 10 gig NICs, or the equivalent of 28 gig fiber channel interfaces. One machine to one machine, full stack. SMB client to SMB server, to storage spaces, to the disk, right? Now that's fine. Let's try this with some smaller I/O. So I have another workload here. Let's run this guy. This guy is now doing 32K I/Os, which are smaller and are aligned with that workload we said, have some VDI workload or something like that. Let's look at how that goes. So we are doing 330,000 32K I/Os per second. Okay? So that's over 300,000 32K I/Os. Most people doing these kinds of I/O demos, they do 512-byte I/Os, 1K I/Os. I'm doing full 32K I/Os. Okay? This system with 8K I/Os, I think it goes over 500,000. Now, that's all fine and good, but what really matters here is we want to see how this performs from a VM perspective, right? So, as I showed to you, I have the VMs, all the 12 VMs waiting for a file to be created. I'm going to go ahead and create that file that they're waiting for, and we're going to watch the performance here. Let me show you the script. The script is somewhat like this. If there is a file with a Go extension, run this, then sleep, then run this, then sleep, and then keep going, right? I'm going to go ahead and create the file. Let's watch the performance. First, large I/O, 16.8 gigabytes a second from the 12 VMs combined, okay? So that means that if I bring up my come on. I have this auto-hiding. There you go. So it's running there. You can see my VMs are all kind of going there. This is actually not a very busy workload. Now, next one, I'm going to switch to small I/O, right? So it ran that for about 30 seconds. Now the script is going to go small I/O. So it starts now. So already at 300,000 from all 12 VMs. They kind of kick in, right? So what we're doing here is about the same, 320-something thousand I/Os per second. I'm going to delete the file before it loops back in. But what we're showing here is both 32K, 340, 352. Hey, Jose, wait. You're doing better from inside. I'm queuing more I/O there. So there's more VMs running. They each queue a lot of I/O. But that was the short story. So we're actually having excellent performance. How do you do that? With great hardware. So I have SSDs. I have ROMly systems with multiple cores. I have nice network interfaces. However, you saw the demo at the keynote. What was the demo at the keynote? It was about, if I remember right, 8,000 IOPS with spinning disks, and which is another thing that's very common. It's about 20-something spindles with hard disk drive. So we can perform at both levels. I like to do this demo because this is the fastest machine I could ever get my hands on, right? And keep in mind, this is one file server talking to one file client. We can do more if you spread the load. Now, I wanted to do one more demo, if you don't mind, which is I'm going to take that first demo I did, and I'm going to let it run for longer. So I'm going to run for a long amount of time here. So you see my workload is currently running there. I'm going to switch to another performance monitor view here. So this is just looking at byte per second. So we're at 16 point something gigabytes a second, right? Now what I'm going to do is talk a little bit about resiliency. So I'm going to bring up my network configuration. You see I have a few interfaces up. One of these is one of my 54 gig interfaces. I'm going to go ahead and disable this NIC. What I'm doing here is the equivalent of pulling the plug on one of my 3 NICs. So I have 3 NICs on each side. I pull the plug on one of them. What you see here is my workload continues. I just dropped my throughput to only 10 gigabytes a second, okay? Now, the more interesting thing to do here is not only we can take that, but we can also re-enable that NIC, right? And what happens here is the stack will eventually detect the fact that that NIC came back, and SMB multi-channel will kick in to reevaluate what it can do, and it will bring the performance right back up in just a few seconds. So this is network fault tolerance, right, at full load. So we're doing the full capacity. And all the while, if you look at the workload that I have here, SQL.io is happily moving forward. There was no error, nothing. It was just like nothing happened, right? So in this case, it just survives a network outage. We can do similar demos in regards to node fault tolerance. Well, let me go back here to my slides. I have just a few things to go over, and I don't have much time left. So that's a summary of the demo. You can take a look later. A little bit about sample configurations. So a lot of folks ask me, Jose, have you tested this? How are people using this? How is this working end-to-end? So a few things. For instance, you get this configuration here, simple 1 gig NIC connectivity, comparing 2 gig fiber channel connectivity with direct attached storage versus Hyper-V over, in this case, it was just SQL over SMB in that configuration. We got pretty much the same throughput. How is it possible that 1 gig gives the same throughput as 2 times 4 gig fiber channel? Because fiber channel was not the bottleneck. The disks were the bottleneck. So in this configuration, you were doing too much on the connection to that storage. With 24 10K disks, we were never able to pull that with that workload. So be careful with your end-to-end configuration. Another one, this is a white paper we published comparing SAS drives connected directly to a machine, to a Hyper-V box, then SAS drives connected to a file server connected to the Hyper-V box. Again, showing the configuration running within 5% of the original throughput. Another one comparing non-RDMA 10 gig with RDMA 10 gig. So non-RDMA through SMB, 1.129 megabytes a second. That's essentially line rate, right? With about 10% CPU utilization, right? Now, you switch to an RDMA interface, not only we go 5 times faster, but we use half the CPU while doing it. Not sure if I had all the CPU numbers up on the demo that I was doing. If you were paying attention, for the large I/O, we were actually a very low CPU utilization. Later, if you can review the deck, take a look at those details, that'd be great. And here, in this case, our local storage was able to do 5.8. It was 4 Fusion I/O cards. So this was essentially what the local storage could give you. Similar configuration with Supermicro gear, 4 RAID controllers. This was no spaces, just SSD straight up to RAID controller. 2 54 gig NICs, similar number. You know that 10 point something is the limit there, right? Because we showed We could go a little higher than 10. In this case, the bottleneck was the local storage, which could not go much faster than 10. Latency also really good. This is essentially the system we have right now. Have the 8K number there. We also have demonstration by XIO, so fiber channel storage front-ended by file servers, 15 gigabytes a second, 120,000 IOPS. This is 120,000 IOPS from spinning disks, right? So this is the XIO demo more than anything. Cluster-in-a-box solution, I didn't talk much about these. They have these systems that can give you if you don't like to do the SAS wiring yourself, you can buy a box that has 2 servers, all the SAS drives and all the connectivity to the drives is in a single sheet of metal, okay? We did a demo. There's a link there to the demo, so showing this is a transparent failover, so it's on one node and fails over to the other node. That's how it looks on the performance monitor, switching nodes. This is the Store Easy 5000 from HP, also a cluster-in-a-box system that you can use as a storage solution with SMB file server. This is the Quanta cluster-in-a-box. We also demonstrated that with the LSI HA-DAS, which is now called, I believe, LSI Synchro solution. That's a clustered RAID controller. In this case, performance was 2.5 gigabytes a second, limited by the PCI bus. That's a Gen 2 by 8. I believe that's what there was the limit there. It's a sweet machine, a violin memory prototype. This is not SSD. This is an all-flash system, right? So what you see there, these are memory modules on the machine itself. And on the side, there's the 2 CPUs and the network interfaces. Again, a very nice, compact 32 terabytes of flash that you can drive through SMB. We're doing live demo with SQL at TechEd, showing some really impressive numbers as well. This is an interesting data point. Sorry, I wanted to call your attention here. This is the VM boot time without CSV caching for 5,000 VMs out of a file server cluster. So we had a single file server cluster in scale-out mode hosting 5,000 VDI VMs. So we boot everything, right? So we do a boot storm on this guy. Without CSV caching, the average time to boot was 211 seconds. Now, with CSV caching enabled, 29 seconds for the 5,000 VMs in average, okay? So very interesting. We also have the 2,500 VM. So this is also something we did internal testing. That's a Hitachi SAN backend. A few systems here that we have demonstrated. This one, if you ever use the virtual labs on the web, this is running on a Hyper-V over SMB configuration, 50 hosts, 5 file servers, 7 fiber channel arrays in the back. This is a system we're working on actually this week with Microsoft IT. This is coming up this week, and they call it a Microsoft IT scale unit. So 28 Hyper-V hosts, dual 10 gig, non-RDMA, going to 4 file servers in a cluster with an EMC vMax in the back. And finally, this is a hoster in the UK that has 2 setups, one with all 1 gig storage spaces back end with Dell servers. So these are all JBODs connected through 1 gig. They do something interesting. They do 8 1 gigs to get the aggregated throughput, right? And on this new deployment in another site, they're doing 10 gig networking, 4 10 gigs in a team. So also some impressive scalability numbers. So I'm about out of time. What I wanted to say here, first of all, I know this is all new in Windows Server 2012, and I know you guys are just starting to experiment with it. I would highly encourage you to just play with it, as the T-shirt said, right? Don't believe anything I say. Go try it out yourself. Go test it. Go play with it. And we have a lot of guidance available today so you can deploy this. We feel very confident about it. We have been doing this for a while. some of these, for instance, the hoster configuration that we're showing here was deployed a few days after we went RTM. So it's been running for some time already. And I welcome you to visit our documentation on TechNet, the blog at smb3.info. And please fill your evaluations. And if you have questions, please walk up to the mic. And I think we can take a couple questions still. Okay? Mics are on? Go for it.
I just want to find out about thin provisioning. I mean, one of the things that that you can typically do on a SAN is use thin provisioning. Like, is a thin provisioning system here dynamic disks?
Yeah, so thin provisioning is a feature of the underlying storage stack. So we can absolutely leverage it through Hyper-V over SMB. And if you're talking about spaces specifically, there are limitations if you're doing clustering, right? So for clustered storage spaces, you need to have mirrored spaces or simple spaces, no parity, and we don't do thin provisioning, okay? Now, having said that, you can use dynamically expanding VHDs, which in my mind is a form of thin provisioning as well, right? Make sense? Any other questions?
Yeah, when spanning multiple RDMA NICs, you're not using LBFO teaming, are you? Or if you are not, are you putting gateways on every single one so you can go out the subnet, or are you just using a gateway on one? Or from a NIC perspective, how is that going together?
Okay, so this is about network configuration, RDMA teaming. So we fully support teaming for non-RDMA NICs, and that's fine. We'll work well over those. If you're doing RDMA, we ask you that you not team the NICs. Why? Because if you put a software layer between us and the NICs, we can no longer program the RDMA capabilities into the NIC. So if you're using RDMA, you want those NICs bare, okay? This example that I showed is you team the NICs that go into the virtual switch to the VMs, but the NICs that you use for RDMA connectivity, you don't team, go straight out. The way that works is you don't need a default gateway on those. You actually don't even need to publish those to DNS. So all you need is at least one of your regular interfaces with the default gateway so that we can find out the other side. Then SMB will query the other side, gather the information, and switch the RDMA NICs. SMB always prefers the RDMA NICs. But it could be a private network, no default gateway. Just make sure they're on separate subnets so that cluster can recognize them. Okay? But that's all it takes. There's plenty of guidance, by the way, on multi-channel on how to configure this.
Question on the RDMA data transfer process.
Yes.
So if you have an RDMA NIC on host 1 and RDMA NIC on host 2 and you want to transfer a block of data, how does it account for like packet loss or network latency or network issues? Like what TCP does, desegmentation, reassembly.
So this depends on the RDMA network technology you use. So there are 3 different types of RDMA NICs. One of them is an iWarp NIC. The iWarp NIC runs a TCP/IP stack on each NIC. Not to be confused with the TCP/IP stack that Windows runs. So there is actually a TCP/IP stack inside the NIC, and that is used to do the transfer, and it provides the guarantees. There's another one that's called RDMA over Converged Ethernet, which is ROCE, which is just raw Ethernet. In that one, we actually need to have DCB on the network so you can guarantee isolation from these losses on the network. So DCB has some Ethernet-based non-TCP guarantees that can be done through DCB. The third option is InfiniBand, which is the one that I use in the demo. InfiniBand has its own guarantees as well, so we don't need TCP to provide those guarantees. But in all cases, yes, we can guarantee that you don't suffer from packet loss. Yes?
Hi, question about the Active Directory dependency.
Yes.
If for some reason you have an interruption to your AD, does the entire solution completely fail?
If you don't have Active Directory in the picture, what happens is you can't configure the correct permissions for Hyper-V over SMB. Because when you try to grant permission based on a computer account, there are no computer accounts.
Okay.
That's a limitation of our permission model. And for clustering as well, we have to create the computer accounts for the cluster resources so we can authenticate against those computer accounts. So we use Kerberos authentication, which is the way you should always deploy your file server authentication. And the component that provides Kerberos authentication is Active Directory. So that is the highest level of security you can get. We absolutely recommend that you use that. So without Active Directory, you don't have the end-to-end solution. There are folks that talk some really crazy stuff about granting permissions to everyone to make this work. I'm not even going to comment on that. That doesn't exist.
Gotcha.
Right? So deploy it securely with Active Directory.
Okay, thank you. Follow-up question regarding the RDMA.
Sure.
Is there some sort of validated list of qualified RDMA devices or some sort of test to say that your NIC is actually RDMA enabled?
Yes, so we have, the way you do it is you go to the get SMB server network interface or get SMB client network interface command line, and it will tell you if the NIC is RDMA capable or not.
Okay.
That is what you can use to check.
Okay.
We do have a logo program for our network vendors, and they have to certify that. Today, we have NICs available from Intel, from Mellanox, and from Chelsea that provide RDMA capabilities. Different types, 10 gig, 32 gig, 40 gig, 54 gig, available today, and more are coming.
Great. Thank you.
Okay. All right, I think we're out of time. Thank you very much for coming, and look at the blog for the demo details. Okay? Thank you.